Well, welcome everyone. We are starting our third week of data science and technology. And what we are doing today is we're going to start taking a look at Python and Google Colab. But before we do, let me just check, are there any questions from week 1 and 2? So our first 2 weeks of the class, we're kind of focused on sort of, what is a data science project, sort of what is data science, and, what do I do for a data science project? And now we're going to start talking about more of the hows, okay? How do I do data science? What are some of the tools and techniques that are available to me? But let me just pause for a moment. Any questions from week 1 and 2? Anyone having problems getting the recordings? Anybody? I think the main thing with the assignments is some of the assignments, it's very easy to get a certificate. Other assignments, you complete it and it doesn't really tell you, it doesn't produce a certificate or a badge. If that's the case, not to worry, just provide some screenshots showing, for example, there are green check marks next to the modules, or if you want to do screenshots showing that, look, there were 10 quizzy questions and I got, 8 right, so that's 80%. That's all good. So we've got some flexibility to make up for some of the inconsistencies in cognitiveClass.ai. Okay. Well, I will say if anyone has any questions, I don't see anything right now in the chat or in the classroom. You can always send me an email. Let me know if there's anything that you have a question about. Okay. So let's talk about week 3. Okay. So if you open up week 3, what I'd really like to do today, if you click on Introduction to Python, I want to take a look at Python. This is a popular language choice for getting your data science projects done. Now, I will make a note that I think on Thursday, I will talk a little bit about R. I will talk a little bit about other packages, other options you have for doing your data science project. But Python, and we can take a look a little bit at this, Wikipedia had a very nice overview of Python. Python has been around, well, officially, it was released in the early 1990s. So it's been around now, 30 some years. It was originally developed as a general purpose programming language. It has become very popular now as a web programming language, for example, a web server programming language. It is also, because it's very easy to learn, it has become also popular. Let me put it this way. I sat in on a course about 2 years ago where it was essentially Microsoft Azure, and they were using a coding language so they could basically spin up their virtual machines. It was, how do you do infrastructure as code? And they used something that was very Python-like. And then along the way, people started building data analysis libraries for Python. And so over the years, Python has become increasingly popular as a data science language. And so the other reason that I've been leaning a little bit more towards Python is that I've noticed over the years that many students like to choose Python for their data science projects. There's a lot of support from Python. We'll see that Google really likes Python. The other thing about, I was going to say about Python is that as your data gets bigger, and this is, you might say, so why are we using a programming language to do our data analysis? Well, it really has to do with the fact that as data gets bigger and bigger, the typical tools we would use to work with our data, for example, spreadsheets. Just out of curiosity, anyone know what's the limit on a typical Excel spreadsheet? That's a trivia question. What is the max rows and columns in Excel?
I think it's 1048576.
Yeah. And it depends about what file type. But this is what typically happens is usually there's a lot of packages actually have a limit, which you might say, wow, I mean, for a lot of conventional data sets, I'm not going to have to worry about that limit. But in the realm of big data, when we're starting to talk about terabytes of data and petabytes of data, yes, you start to exceed the limit of these packages. So you either have to find a package that maybe has been designed to run on top of a Hadoop cluster, or you need to get, for example, a data science language like Scala or Python, or now we're seeing, R is also has had software developed, so you can take your Python code or your R code or your Scala code, and you can run it on a cluster, and you can basically scale to how many, I want to say, petabytes, exabytes, whatever you have, to handle to capture the data that you want to look at. And so that's kind of the motivation for Python. Now, you have a lot of options for how you want to work with Python. I listed some of these things here. Python is open source. You can go visit the official Python website. You can check out some articles on some of the most popular Python libraries that are out there. There are also specialized libraries. I picked on BioPython because we have a bioinformatics program. They tend to prefer R. And that is because when it comes to doing, for example, various tasks like RNA sequencing, I think R right now kind of has the edge in terms of having the specialized libraries in the area of, analyzing, RNA and DNA. But you can see people are interested in getting Python into this area. So at one time in when it came to analyzing genetic data, I think the top three, it was, R was number one. And then, you had this BioPython, and there used to be something called BioPerl. I think BioPerl is still around, but it has kind of dropped to sort of a very distant third. So, but as I say, one of the things you'll find is, when you're thinking about a data science project, who has the best tool for what you want to do? Okay. And I had some instructions. I used to spend a lot of more time talking to folks how to download and install Python. However, I have found now with the cloud-based tools that yes, if you wanted to put, Python on your laptop, you can certainly do so. But I want to show you another tool, which is the Google Colab. And I have a couple other links I'll just mention There's, by the way, tons of Python tutorials. Today I wanted to demonstrate Python for data analysis. But if you're wanting to say, well, can I just get some general background on just basic programming with Python, W3 Schools is an excellent resource. And Python itself, the Python Foundation, has some nice tutorials too. Okay. All right. So this Google Colab, what exactly is this? Well, Google Colab is essentially based on another product called Jupyter Notebooks. So, if you go into the Google Suite, you're probably familiar with Google Docs, which looks a lot like Microsoft Word, and you're familiar with Google Sheets, which is a lot like Excel. And then there's Google, I think, Slides, which is very similar to PowerPoint. Well, there was another product out there. It was an open source project called Jupyter Notebooks. And the Jupyter was based on, it was originally designed to help folks develop their data science projects in one of three languages, Python, R, and then there was a third language called Julie. Jupyter Notebooks now supports many languages, C+, just about any language you can think of. They've got about 40 different languages that they support. But Google, in Google fashion, they took the open source code and they have developed this cloud-based resource that they have two tiers. They have the free tier, which of course we want to use. There is a paid tier. It turns out the difference between the free tier and the paid tier is really the guaranteed response time. If you're on the free tier, and I've always found on the free tier, for what we need to do, the response time is quite good. But if you were running bigger data science jobs, you might want to be on the paid tier to have a guaranteed, service commitment, in terms of performance and response. So I think the big difference is if you're on the free tier, you kind of, you're on the fringes of their cloud in terms of performance, but they have the better performance reserved for their paying customers. So what was the idea of these notebooks? Well, it goes back to the idea of the scientific notebook. And let me open this image in a new tab because it's oh, that's teeny tiny. Okay, let me just open this up. Okay, so what do we mean by a lab notebook? So this has been used in the scientific community for hundreds of years. And scientists would basically keep this one is from 1876. This is where scientists would put their drawings, they would put their formulas, they would put down their hypotheses, they would put down the details of their experiment. This is where they would keep a journal of what they were doing in the lab and whether, what the results were. And here, I'll give you, here's another example. Here's another image. I think Otto Hahn, I'm trying to remember, I think he was a physicist. But anyway, these notebooks, and you can, nowadays, they even have, for the famous scientists, people have, museums and have acquired their notebooks because it's not just a record of their thought process, but for these scientists, these journals is what helped them to then write their papers. It helped them to keep track over the years of what was working and not working, and maybe they would want to go back and revisit an experiment to refresh their memory on what they had done and maybe there was some, new technology and now they wanted to redo their experiments. So this was the idea of the lab notebook. Okay. All right. So they took this idea and they put this into Google Colab. And you can go ahead and click on Google Colab, and it will come up, and you can, by the way, it's very nice that we have our email that, comes with the Google Suite. Because if you go ahead and say, I would like to create a new notebook, yeah, let's go ahead. We can start off with a blank a notebook. These will get saved to your Google Drive. So that's very handy. So I'm going to go ahead and we'll just say this will be our, we can call it whatever we want. We'll call this data science Python, February 4th. Let's call it demonstration. Okay, we can give this, whatever name that we wish. Okay. I'm just curious, show of hands, how many folks have played around with Python? Okay, we got some folks who played around with Python. Very good. Very good. You have. How many folks have played around with Google Colab? Oh, we got a couple hands. Google Colab. I have really moved towards the cloud because it doesn't matter whether you have a Mac, a PC, a Chromebook, a Linux machine. It is just so nice just to say, hey, just click on this link, click on Open Notebook, and there you go. Okay. Now, when you first look at this notebook, you're like, well, this seems pretty empty. There are two types of cells that you can put in here. Let me start off with a text cell. So the couple things that you can do is, let me just see if I can, okay. Okay. All right, let's see if I can do this. Oh, okay. Just see. Okay. There we go. It's lowercase. Let me try lowercase. There we go. Huh. So one thing you'll notice, and here, let me just make this a little bigger because I can just see people are probably squinting their heads off. Okay. All right, that looks better. So a couple things. You have two types of cell blocks. You have code cell blocks where you can put in Python code, and anytime, by the way, that you can go back and double click to edit your code. So maybe you just say, well, maybe we want to be more formal and we want to say hello. And then there's a little button that allows you to run that code block. And you'll notice that Python is case sensitive because I first put in a capital PRINT and it said, gave me an error message. Okay. So you got code cell blocks, and then the other thing that you have is, let me just put this in here, you also have text. And you'll notice that, oh, well, this looks a lot like email. I can go ahead and I can say, this is some text for my notebook. And there you go. And you can kind of play around, and maybe you want to make it bold. Maybe you want to make it italicized. You may want to insert a link. Maybe you want to insert an image. Maybe you want to add a numbered list. Maybe you want to add a bulleted list. You may want to add horizontal lines, switch to latex, insert emojis, pretty much anything. If you've done anything with web design and are familiar with HTML, pretty much anything that you could use your HTML markup language to do, you can use in these text boxes. And so these notebooks can become very, I was going to say, very rich. I have a link. If you go to this Python tutorial for analyzing and visualizing data, this is what this looks like. And, when you see this on the web, your first thought, oh, this is a website. But if you look carefully, this is actually a notebook. And you'll notice that they have it set up just like they would with a report, with an introduction, with headings, with text, with explanations. And these notebooks, whether it's Google Colab or Jupyter Notebook, have become very popular. For example, if you go to Kaggle, you'll notice that for a lot of competitions, they will ask teams to submit their solutions via a notebook. Notebooks are really kind of neat because they not only allow you to combine your explanations, your background, you can add your references. You can basically turn these notebooks into an interactive report where you have all your descriptions and explanations and your documentation and your interpretations and your discussions. And at the same time, you can have your code. And it's interactive, meaning if folks load this into their notebook, either Google Colab or Jupyter Notebooks, and if they have a copy of your data, in theory, they can replicate your results. They can see, oh, this is the code this person was using, and I can see exactly how they got their results. So as a form of documentation, and as we mentioned, Kaggle, a lot of hackathons, competitions now have people do their work as a notebook. In terms of your data science project, now I've had some students do their entire report as a notebook. You can do that. I've had other students say, well, I prefer to do my report separately, but I would like to attach my notebook because that will show you all the code that I worked with. Okay, so this particular notebook is actually taking a look at a data set that comes from this Kaggle challenge. And so this was a challenge. It looks like it's from a couple years ago, but this was a data set with features like make, model, year, engine, and other properties of the cars. And it was used to predict its price. And so this is an example of a typical data science project. The goal of this challenge was to predict the price of a used car. And I wanted to point that out because as you're thinking about what you want to focus your data science project on, it doesn't have to be extreme. It could be something very basic. I've seen the commercials of apps and other things that people use in order to, try to find, what is a fair price for this used car. And I'm just really curious to know, well, how would I do that? And so you can do a very nice data science project where you can go, locate, a data set and do the analysis. And you'll see that even for something that seems pretty straightforward, here are a bunch of properties about a used car, predict its price. I think you'll find that just doing the exploratory analysis, getting the data set cleaned up, trying to fit different models, trying to see what works, what doesn't work, it's a great learning experience. The other thing I wanted to make sure I made a note about is, in addition to getting your idea, definitely before you kind of rush into trying to find some data, definitely take the time to just Google the internet. First start off, if I'm looking for a used car, how do I figure out, what are some tips for how to figure out a fair price? And so again, that can go into your report as your literature search. But it's a good idea. Take some time once you have an idea to just go out and see what others have done. What are some of the most popular apps out there for predicting used car price? What do they look at? What do the experts say? If you're looking for a used car, and get some ideas, get some background. And again, everybody's a little different. Some folks may have already been familiar with the process of buying a used car. But if you, for example, are not a car owner, or you've never bought a used car, getting some background information is very helpful. And again, make sure you document your references and put that into your report. The other thing is there's a lot of data sets out there. And so that's another thing. Again, you don't necessarily want to jump on the first data set that you come across. As I say, this one is about, from 8 years ago. If you start to Google, used car data sets, check to see what's out there. Again, that gives you something nice to write about. I went out and, looked around, and, of the data sets that I looked at, here were sort of the top 3 that I considered, and, explain, why one particular one was really good for your purposes. Okay. And at any time, if you have questions, just, raise your hands, or, put something in the chat. Okay. Here you can see some of the information here. Let me see again. Let me see if I can make this a little bigger so folks can see. So this particular data set is a CSV file. And what can we tell you about this data set? Well, they have, it contains the make of the car. So things like Chevrolet, Ford, they have others, BMW. The car model, whether it was Silverado, Tundra, they have the year of the car. And they have a data set going from the 1990s to 2017. What else do they have about the car? They have a little bit about the engine fuel type. They have some things like, what was its horsepower? And this is kind of nice. You can kind of see a visualization here that there is, you'll notice here that there are some cars in that data set that are on the high end of the horsepower. And let me just see again. Okay. Let me see if I can just, let me just, what else do we have? We have the number of engine cylinders, the transmission type, whether automatic or manual, whether it was front wheel drive or rear wheel drive or all wheel drive, whether it was 2-door, 4-door. We have the market category. That's kind of interesting. Crossover. You can see that they have some labels for whether it was luxury, luxury performance. They have hatchbacks. So they have a number of of categories here. Oh, they also have some things. They've got a vehicle style, highway miles per gallon, city mile per gallon, something that talks about its popularity. And yeah, so you can get some information about it. And then if you log into Kaggle, and you can log in with your Google, you can go ahead and you can download the data set. And yes, and this is, again, you can kind of see there was 16 columns, and as I say, you could actually analyze this data set in a spreadsheet because it's 16 columns, and you know, if we scroll down, yes, it has quite a few rows. It has about 12,000 rows, but that's certainly manageable, for a spreadsheet. But this is nice, you always want to, if you can download, if the data set is too big, maybe you'll just download a sample. But it's nice to be able to actually, look at this data and see what it is. Okay. So one of the things that when you're first, learning how to use these notebooks and Python and data analysis techniques, I really do like to start off with somebody who's put out a notebook so that I can learn from it. And what's kind of nice is things that you can do is you can copy the selection, and we can, I was going to say, one of the nice things we can do is, we can go ahead and you can copy and paste. Usually the thing that you also want to do when you copy and paste is you also want to spend some time, and this is where it's very nice to put your comments. But typically, you have the Python language. But in order to really use Python for data analysis, you want to use some libraries. And so we can take a look at, these are some of the popular libraries for getting started. And I think, let me see, do I have some of these? Let me just take a look at some of these. You'll notice there's quite a few libraries here, but let me just see. Oh, Python libraries for data science. There we go. Okay. And you can see, yes, there's a lot of neat libraries there. So some of the ones that are just, I want to say, selected a lot is NumPy is very useful for scientific computation. So it's very helpful. It has all these built-in mathematical functions that, because it's built into the library, you don't have to program. The other thing about Python is, you bring your data set in and you want to be able to do things. You want to select rows. You want to select columns. You want to be able to, work with your data. And so native Python is, it's a bit of work to try to manipulate your data. But some clever group of people came up with pandas, which is very useful when you need to do data analysis, data manipulation, and data cleaning. It has a lot of functions to make that easy. Another one is, yeah, we want to also do visualizations. And so there's a number of libraries. I think Matplotlib is very handy. And another visualization library is Seaborn. And so again, that allows you to do a lot of neat visualizations. Plotly, very useful for graphing functions. If you're doing machine learning or regression, you might want to use scikit-learn. They also have things for machine learning. We've got a couple libraries there. When I need to do regression, it's kind of interesting. I really love StatsModel. Scikit-learn will also do regression, but I like the diagnostic capabilities in StatsModels. And then there's a whole bunch of others, specialty libraries. We've seen PyTorch, Keras. Oh, this is one we'll take a look at when we get to text mining. The natural language toolkit is very helpful. But now there's some other ones, Spacey and Hugging Face has these pre-trained models to help you when you want to do text classification, image classification, audio classification, or multimodal like video classifications. So very, very helpful. In fact, that was such a good reference. I better add that in. Let's just edit the content here, and let's just add it here. I want to say Python also has a growing list of libraries for data science. Yeah, let's go ahead and capture that. Okay. And let me just, okay. So we looked at this, and let me just close this one down. Okay, very good. And then this is the one that we were learning with. Now, sometimes when you run a cell, you don't really get any output, and that is because we really didn't request any output. All we're doing in this case is we're importing the libraries that we want to use. And here, let me just point out the features here. You'll notice in this color, we have the Python command to import. We have the name of the libraries, or some of these libraries have subsections, so maybe we don't want to load the entire library. We just want to load a portion of the library. And you'll notice these things: PD, NP, SNS, PLT. This is shorthand. This means that when we want to pull in a function from one of these libraries, we don't want to have to use the whole library name. We like to use some shorthand, so we don't have to type as much. This Matplotlib inline, it is basically a instruction that says when we use Matplotlib to produce a chart, we want the chart to appear under the code cell. Because otherwise what will happen is you do have the option that it will produce the chart, but maybe you'll put it someplace else. And one of the nice things you can do is when you're trying to teach yourself Python is just to say, what does, is basically just when you come across code and you're thinking, what does it do? Go ahead, Google it. And you'll typically get a source that will tell you, hey, this is what this piece of code does. You can also play. You can actually, comment out that piece of code. See what happens when you try to run your cell without that piece of code. And this one, and you'll notice here, is referencing, it's an instruction for the Seaborn library. And it turns out the Seaborn library has some options for, I think, your color palette. And so this one is basically just kind of think specifying well, we can actually, let's do copy selection. It has to do with the, it basically is setting what color codes you want to use. And you'll notice here I'm being a little lazy because I just wanted to know in general, okay, so that is just a line that kind of sets the color palette. You can see that you can dig a lot deeper into the documentation. And of course, you can always play around to say, hey, if I comment out that line, hey, what happens to the graph colors? So it's kind of by playing around that you can kind of figure out, hey, what is this piece of code doing? And that's, I think, the other thing we like to tell students is definitely the way you learn is by starting off with notebooks and playing around with them. And the key thing is to give yourself the time to explore. So again, it comes back to time management and project management. This is why you want to pick your data science topic early, start doing the background research, start investigating the data sets, and then give yourself time to look for examples of code that you'd like to do, and give yourself the time to really explore and Google and play around to figure out what is this code doing so that you understand it. And that's a big deal when we have students in our Masters of Information Science. When they deliver their master's project, we always quiz them on, okay, so what is this section of code doing? Because we want to make sure they're just not blindly getting a notebook and just running the notebook, which you can do, but do you understand what the notebook is doing for you? And of course, there's no problem at all. You can add comments so that, each line of code, you can have a little note to yourself. Well, this is what, I'm importing, the Panda library. So now the next part that I want to do is, let me copy selection. Now, if you go to the Python introduction, I've got this original Python tutorial. Actually, last week, I wanted to make sure that Python tutorial was still up to date. So I ran it myself. And what I did is I found that there were section code blocks that were no longer running. They ran last year. They weren't running this year because, the libraries had been updated. They're using a different, they've updated their version of Python. They've updated the libraries. And consequently, some of the commands that worked previously now we're throwing an error message. So this second version here that says with Pierce updates, that has a PDF of all the code that I checked, and at least as of last week, it was working. And so one of the things that I also added, okay, is, and what this is doing here is I went out to the Kaggle data set where they had that used car data set called data.csv, and I downloaded it to the to the computer. In fact, you can even here we go. Here we go. Yeah. So I downloaded it down to the computer. It came down as a zip file. I unpacked it and I just copied the CSV file out. So it's just sitting in my download file. And I'm using a little set of instructions from google.colab import files. And what those, and then it says uploaded equals files.upload. What that is that is a little instruction that says, hey, Google Colab, when you see this command, I want you to open up a dialog box that is going to allow me to select the data.csv file and upload it into into Google Colab. And then what I want to do is I want to use the PD, which is the Panda function, and I want to use the read CSV file. And what I want to do is read in this data.csv. And this next line, notice the little, it's in green, has a little pound sign. That's how you get a comment in. I want to use the data frame.head command to display the first 5 rows. So notice it's now kind of waiting for me to upload a file. So I'm going to open up this file. Okay. And now I have my data set into Google Colab. So now what I can do, and notice it has, this is a new feature I noticed this year with Google Colab. It didn't have this in previous years. Notice it's even, that's because it's got the AI now. Google Colab now has this AI engine in the back, trying to suggest, well, here's what you might want to do next. But in our case, we're like, no, I just want to add another code window. And what are some of the things that you can do? Well, there are a lot of basic commands that you can do to play around with your data. So we noticed there was a df.head command that basically said, show me the first 5 records. What if you wanted to see the last 5 records? Yeah, there's a tail command. Are there other commands that allow you to basically specify, show me records 100 to 105? Yes, you can do that too. And for a lot of these things, if you ask me, can you show us? Well, I would say, well, here's what I would do. How to use a df command to display, I don't know, middle 10 records or something like that. Let me just see. And sometimes display records 10 to 20. Sometimes you have to just kind of Google around to see And sometimes you have to, I'm seeing head, I'm seeing tails. I know there's a way, yeah. I'm surprised that is, it's so interesting. People just are interested in the first five and the last five. Or display all rows.
You can use head to display the first 10 or first line.
Right. Yeah, but this is where you end up. Oh, I'm surprised. I'm pretty sure if I uh, uh, I am sure it that you can get other. I've seen the command. It's just off the top of my head. Um, uh, I'll have to research that. How about folks online? Does anyone recall if you wanted to see how to use DF to select rows in the from data frame? Just see. Okay, but now, but there may be some other things like uh, you can select rows by index position. You can select by a column name. I think this is the one I was thinking, by the start index, the end index. So notice you can, that is, it must be the location. So you can almost put in some SQL-like commands to be able to look up, various rows. There we go. Okay. So what were we Googling on that we found this? It's a good question. Okay.
Dr. Pierce,
Yeah.
I see where you are going through the data.csv file. Where did you get the data.csv file from?
Yeah, that one. I ended up going to the original one, and what they uh, uh, did here is in the original in the original notebook, they actually had some information about where the data set came from, and you can find that right here. It's they were using the Kaggle.com Cooper Union car data set.
Okay, that helps. Thank you.
Yeah. So I actually put those notes in the intro to Python because I knew I would never remember that. Okay. Okay. So let me just show you a couple of things. And so, as I say, the DF is basically that's my shorthand, basically for data frame. You could call your data frame anything. You don't have to call it DF. But that is a convention. A lot of people basically, when they're working with structured data, they're loading it into, a tabular array format. And that's in Python is kind of what we refer to as a data frame. So what are the things that you can do? Well, you can do things like see what type of data that there is. And again, we can replicate that. We can, what I tend to do is, because I like to copy the selection, just so I can get the code, exactly right. Okay. What else can you do in Python? Well, it turns out that you can drop certain columns that maybe you don't feel are useful to your analysis. So, in this example, what did they decide to check? Now, they decided, and again, I think this is more, not so much about doing the data analysis, but just showing the capabilities of Python. But a couple of things that you can do with this data frame is maybe there are certain columns or attributes that you don't want to take a look at. So they wanted to get rid of engine fuel type, market category, vehicle style, popularity, a number of doors, a vehicle size. And really what they're saying here, if you take a look, is they're saying take that data frame, and they're using the drop function, and they're giving it, notice they take the name of the attributes, and they're putting them into single quotes, and they have a list of the attributes that they want to drop, and then they say, well, now show me the next five, show me the top 5 rows, just so I can kind of see that those columns, in fact, were dropped. And we can check out to see, hey, does that code, still run? And yeah, it does. And now if we want to say, well, what happens now when I do the df.data types, and now I want to notice here, I have a smaller list of attributes. And what's really nice about this is, once you have the data, I mean, you can hardly go wrong. I mean, even if things got totally screwed up, you can always, start over. One thing I will tell you when it comes to running your notebook, you do have to run things in the order of the cells. And by the way, you can take cells and you can move them around. So you can arrange your notebook all different ways. But when you're running your notebook, and by the way, you don't necessarily have to run all the cells one at a time. You can actually do a run all command. But very much, for folks who've done programming, you know that the code gets run in the order that the, in the sequential order that the code has been set up in. So the most common thing that can sometimes happen is sometimes you'll go to run a cell, and the previous cell that it depends on has not been run, and you'll get an error message, sometimes just because, well, look, you're running the cells out of order. You got to run them in a way that any prior dependencies are taken care of. Some of the things you can do, by the way, is they have a shape command. And what that will do when you run that, it will actually tell you, well, here's how many rows that you have, and here's how many attributes you have. Now, one of the things that happened in our data set is that, we removed 6 columns. And, when we did that, we lost some information. It also meant that without those additional details, we actually now had duplicates, meaning we have rows with 10 attributes, And because they don't have those additional 6 attributes that would have distinguished them, they're basically, they have, we have duplicate values. And it turns out there are techniques, for example, for getting rid of duplicates. So, so one of the things you can do is they actually have a function that will print out, just it will identify the duplicate rows in our data set. And here we're actually asking to print out the phrase number of duplicate rows, and then to basically tell us, okay, just how many rows are duplicate. So I'll just put that just to kind of demonstrate that code. Okay. And one of the things you can do, by the way, is you can also drop those duplicates. So we can put in I think that the command was df.count. When I think this is where I do it, it was df count, yeah, with the double quotes. Okay. And all they're trying to do is to show you that we had 11,914 records. But now that we've removed 6 of the attributes, we now have just under 1,000 duplicate rows. Again, this little exercise, what they're really trying to show you is just some techniques. Because typically, before you can do a data analysis, what you need to be able to do, and again, we can do a df.count again, just to see that, did we in fact get rid of those duplicates? A big part of data science when you get your data set is you are going to be looking at things like, do I need all the columns in this data set? You'll be asking yourself, are there any duplicates that are a problem for me in this data set? Do I have any columns with null values, empty values, that would be a problem for me when I try to do a regression analysis? And in fact, there's an estimate, I think IBM once did a study that said, in any data science project, at least 50% of the work is just getting the data set cleaned up and in a quality that we can then do the analysis on. And so some of the other things, in addition, here's the command where we check to see, does anyone have any records where a column value is null? And notice here the .sum says if you find a record that has a column that is null, please count it up for us. And so that's just what this little command is doing. And let's just see. Let's double check to see if this is working. Yeah, and for whatever the reason, we noticed that we have a couple cars that have, they didn't have any value for horsepower, and they didn't have any value for cylinders. And yeah, you could go through your Excel spreadsheet and try to clean it up manually. But this is just trying to show you that, you know what, when we're talking about really big data sets, that's not really very convenient. So here's a little command that basically says, take my data frame, and I'm going to do the drop null attribute function, and then I want to do a count just to show that, yes, again, my number of rows have been further reduced by the number of removing those rows with the that have a null attribute. Okay. And we can actually, a lot of times, we want to check our work. I mean, did it actually work? All right, well, we'll just see. Okay. And now we see, yeah, we've gotten rid of our null values. Okay. Excuse me. Okay. Another thing that we would really like to do is check for outliers. So let's go ahead and let me just, we'll do our first visualization. Oh, and there's one other thing I think I forgot to do. I better do it because it'll kind of mess me up. Here we go. Another thing you can do is not only drop columns, you can rename columns. And so notice here we had engine horsepower. Maybe we want to just call that horsepower. And we had engine cylinders, and we just want to call it cylinders. And we have transmission type that we just want to call transmission. And we want to have, driven wheels equal drive mode, highway, MPG, city MPG. We just wanted to kind of simplify some of our names. So let me just add that in. Let's just, there we go. So that's another thing you may want to do. Just, maybe you don't like the way the columns were, or you want to make them again, make them easier to type. Okay. But outliers can be an issue. Imagine, well, let me put it this way. If you're trying to develop a model to predict the price of a used car, and this is where knowing some background about used cars gets very helpful. So I'm going to do a Seaborn box plot. Okay. And you'll notice that what the box plot does is you can see we've got the middle 50%. And then we have some high-end cars. But you'll notice we have some really high-end cars. And in fact, this might be a good one for me to go back to the original data set. And let's look at the manufactured suggested price. And let me just do a data sort. We'll expand the selection. And let me just sort on that manufactured suggested price. Okay. All right. So we have the used car price. But check this out. Okay. Here's our outliers. What do we got here? At the very, we started off with used cars about $2,000. But you'll notice, what do we have at the high end? We've got a Bugatti, a Lamborghini. We have a Maybach. We have a Ferrari. Yeah. So we've got a Rolls Royce. Yeah, we've got some high-end cars. We're talking, look at this. Cars over $1 million. Cars that are $500,000. Cars that are, $250,000. So one of the things to think about is, okay, for my model, if I'm, what kinds of cars do I have out here? It's pretty hard to come up with a universal prediction model. That's kind of like saying I'm going to come up with like a universal treatment for cancer. This is why it's really helpful to study the used car market, because you may decide You know what? I think the luxury high-end car market behaves a lot different than the Chevrolet, Ford, GM car market. The same thing, you notice that there were no cars older than about 1990. That's helpful because, there is an antique car market. There's a racing car market. So there's these different specialty cars. And so this is kind of helpful to kind of try to figure out, when do I have cars whose prices are maybe so far out there in the tail that they are going to really mess up my model. And so it's not uncommon, if we're really interested in the typical car price, is to say, some of these high-end cars up here, I may just, want to get out of the $250,000, car and try to get down to maybe, the 2,000 to, like 120,000, car range. Okay. And you might say, so how do I go through and identify outliers? And I think, we have just about enough time. Let me give you a, and there we go. So this is where the code in the original tutorial didn't work. So I actually had to find some alternative code. But here's a nice technique. So let's suppose you're looking at price and you say, man, there's some outliers there. Basically some Elon Musk's, Jeff Bezos types of cars that I really, I want to keep my model for the typical used car market. And of course, there's always a couple different ways to do it. This particular data set did have a category like luxury cars. So, there may have been some tags that we could have used. But one technique in the data cleansing space is to use what's called the interquartile range. And what the interquartile range does is that for my data frame, I can take the variable, in this case price, and I might say, let me look at the 25th and 75th percentiles, and let me get the range. What is the difference in price from that middle 50%? So what this little code is telling me is this, basically, you see this little blue rectangle? This is actually representing that middle range. That is the cars that, if we take all the car prices and we sort them, the car that's what we call the 25th percentile, that is the car that 25% of the cars are cheaper, 75% are higher. And then if we take the 75th percentile, which is flipped, it's the car that 75% of the prices are cheaper, 25% of the prices are higher. So it's really the middle 50%, the cars between the 25th and the 50th percentile. We'll notice that the range in prices is about, that difference is about just over $21,000. So this kind of gives you an idea that, we have a huge amount of cars that are just literally, in that $20,000, difference range. And then we have, these are probably then all the luxury cars. And you might say, so how do I go ahead and get rid of those outliers? And this is a neat little piece of code. And it's based on a rule of thumb. Let me just, I'll take 2 minutes just to go a little over. Okay. But this rule of thumb, let me find it for you. Here we go. Open image and new tab. Okay. Okay. So, so there's a rule in statistics, and it's called the empirical rule. And it has a couple parts, but the strongest part of the empirical rule that works not only for normal data sets and noun data sets, but even for really wonky, squirrely, weird-looking data sets, is the third rule, which says that 99% of your data should fall within 3 standard deviations of the center. Meaning, as measured, for example, as in this case of a mound shape is the mean. Okay, so this is great. So this says basically, if you're seeing data that's beyond your 3 standard deviations, you can kind of classify it as an outlier. And particularly if you're not trying to predict luxury car prices, doing typical car prices, you really want to eliminate that. Now you might say, so why didn't we just calculate the mean and the standard deviation and just say, let's cut out any data that's more than plus or minus 3 standard deviations from the mean? The problem is that outliers will inflate the standard deviation and it will inflate the mean. And you can kind of see that how outliers inflate the mean. And we'll just show you the image. Okay. You'll notice that one problem we have with the mean is that if we have a nice symmetrical data set, no outliers, the mean, median, and mode are nicely measuring, they're all pointing to the center. But you'll notice that if we have extreme outliers, that mean is going to get pulled in the direction of the outliers. So this was a big problem in statistics. That empirical rule works great, but it basically assumes that you don't have a really long tail. And so, but somebody probably using simulation was able to show that a nice approximation and things like percentiles are really not as influenced by outliers. And again, you can look at the picture because the median is in essence the 50 percentile. And you'll notice that even with extreme outliers, your median is going to pretty much stay at the center. So the trick that a lot of notebooks use is there's a rule of thumb that says, any data point that is more than 1.5 times the interquartile range below your 25th percentile, and any data point that is more than 1.5 times the interquartile range above the 75th percentile can be considered an outlier. And so we can play this little game that says, hey, go through my data frame, and anybody who has a price, and notice what we'll use the and, because we're basically saying in our data frame, just keep the prices, the rows with prices that are within the upper bound and the lower bound. And that is essentially the trick that we play. And now let's go ahead, and this will be the last thing we do for today, is oh yeah. Okay. Now notice here, now this is what my, by getting rid of basically those top, 1,000 records, notice that's a much better looking box plot. Yeah, I still have some high-end cars, but now I have a much more reasonable distribution of car prices to model against. Okay. All right, we are out of time, but just a reminder here, you can see the original tutorial here, and if you click on this one, you'll get to see mine with all the updates. Oh yes, Lynn is trying to use the Cooper Union. It looks like, Lynn, when I went into Kaggle, it asked me, to log in, and I used my Google. I used my Google email, and it let me write in. So,
Yeah, I was able to log in. I've got an account with Kaggle. I just wasn't able to get to the data set.
Right, did you download it?
No, I was not able to get to it. I kept getting this error. Even after going into Kaggle.com separately without clicking on the link, I would log in using my user ID and then finding the data set. I still wasn't able to get to it.
Let's just try it. So you went to this data set?
Yes. Yep. That's
Oh. Well, maybe the page crashed because that's yeah. So you're getting this error.
Yes. The exact same error. Yes.
So that's interesting. I would say is try again in just I was going to say try again later. It may be.
Yeah, I'll just give it a try a little bit later on.
Yeah, give it a little try. It was working just fine, and it may be. Let me just see. Let's see, this one was, Cooper Union.
Without the space, yeah. There you go.
Yeah, car features. Yeah. I was going to say, give it a try. But the other thing that we can do, I'll tell you what we can do. Hey, just in case that this is a more permanent thing, let's do this. Let's do, tell you what, just so there's no waiting. Oh, I can do this. Where do they have attachments? Yay. There we go. Should be able to handle this.
Oh, yeah, that'll work perfectly. Thank you.
That'll work. Yeah, that should do it. Okay, that should work. Yeah, let's go ahead. Let me save that. There we go. There we go. Thank you, Lynn, because you never know. One of the reasons why I made sure I had access to that data set is you just never know. It may have been that we all of a sudden had 20 students downloading the data set, and that set off some sort of security alarm that, there was some sort of, denial of service attack going on. But that is the data set, data.csv.
Okay, that'll work perfectly. Thank you.
That'll work. Yeah, I'm glad you mentioned that because If they haven't fixed that problem by Thursday, I will really be glad that we have the original CSV file. There we go. All right, so that is good. But what we'll do on Thursday is we'll kind of finish up sort of demonstrating what you can do with Python and data analysis, and then we'll talk about, yes, some of your other options for how you might want to do your analysis. So that'll be for Thursday.